Step right up, ladies and gentlemen. This is our guided hacking Visual Studio Debugger tutorial. I'm going to teach you guys how to debug an external project and an internal one. I'm going to show you some general tips and tricks. And the reason I'm doing this is because a lot of people have errors in their code, or their hack's not working as it's supposed to be, and they copy and paste their entire source into a thread and say, please help me. And a lot of the times, if you would just fire up the debugger and step through a couple of lines of code, you would find the error immediately. So that's the idea behind this. So this is my external Assault Cube aimbot. So I have Assault Cube running right now. So we're going to just show you how to debug this. You want to make sure you're compiling in debug mode. What that does is it provides the debugger a lot more information about the executable and what's going on, and also no optimizations are done. If you were to compile in release mode and debug it, the code wouldn't line up perfectly. You wouldn't be stepping into and stepping over each line quite as nice. So definitely prefer to do it in debug mode. I believe that's the whole purpose behind it. So when you are debugging an executable file, all you have to do is press the play button, and that's going to fire up the executable, and it works fine. The game was found, blah, blah, blah. But what we want to do is we want to put a breakpoint on something and check out what's going on. So let's go down to in main, wherever the hell that is. And just breakpoint the first thing. So let's start over here. Attach to the debugger, the very first breakpoint's hit on the very first function. So basically, we can continue, and that's going to continue the execution of the process until the next breakpoint is hit. We also have stop, and we have restart, which are self-explanatory. We have step into, step over, and we have step out of. And these are included in every debugger. Basically, if you don't know what the hell's going on, you should just be stepping into every single statement and see what's going on. So we are stopped right here. We can see the breakpoint has an arrow in it. It tells us that we're stopped on this statement. So this is a function called setWindow. We want to step into it and see what's going on. So there we go. Here's the function step into. Here's the this shows us where the EIP is, and we see that there are two Windows API function calls here. Now, if we click step into on these, it's actually just going to step over them. It's not going to step into the code. We don't have the source code for Windows API implementation. What we do have, though, if you right click and go to definition, you can see that we do have the header file for this, so that we can see the return type and blah, blah, blah. It's the same information you find on MSDN. Certainly faster than going to MSDN in most cases. So just to test that, step into, it just jumps right over it. Step into that, it jumps right over it. So nothing too interesting there. Let's step into print, and then I will show you what step out of does. So we are in this function named print, and we don't care about it. We just want to jump out of it. So let's click step out of. So as you can see, we're stepped out, and now we have a while loop, which we can step into. This is where a lot of people get hung up right here, is getting the handle of the process and reading the addresses, especially with pointers. So you can step into each of those things one by one, and it's really going to be helpful. So let's see what's going on with get process. We'll step into this. We have if statement that has a call to find process. We'll step into that. So right here we can kind of show you what's going on. Down here we have the autos window, which is going to have all the variables that are being acted on by the current function are going to be in there. I know before I used 2015, it was the locals window that I was using, and now it's the autos, so I don't know what that's all about. But anyway, autos, it will show you the game window and this pointer to what the this pointer is we are in a class member function called find process, and the class that it belongs to is hack class. So every class member function has a this pointer that's going to point to the instance or the object of that class that's being acted on by the function. So let's check out threads. You can see all the threads. You can go to modules. These are all the modules loaded by the current process. One interesting thing here, if you scroll over, it will show you the address range of all those modules, and it will also show you the process ID, which is listed there in hex. Then we have the watch window. This is normally empty, and you can just add anything you want. So, for example, we can add hproc handle. We haven't gotten the handle to the window yet, so it's 0. Another interesting thing we can do, which I always start out with, is get last error, and we can add that in. You can use any expression you want. You can call functions with it, such as this, and the return from get last error was 0x12 in hex. So I'm not sure what that error is, but all you have to do is fire up Google and type in get last error 0x12. And we get to the MSDN for system error codes, and then let's do a find for 0x12, and now we see that this is error, no more files. There are no more files. I don't know exactly what that pertains to, but anytime you get an error, just Google it up and you'll find your answer quite fast. So GameWindow is null. Step over that. Now we're going to try to return the handle to the window named Assault Cube and put it in GameWindow. So let's go back to autos. GameWindow is 0. Now we step over that, and now it has a value. So we know that find window call worked. But so a lot of times what will happen is someone will be using the wrong string type, or using the wrong variable. Maybe you need to use multi-byte character set. Maybe you need to use Unicode. Maybe you need to typecast it to a wide char, whatever it may be. People get strung up a lot in the strings, and certainly I do as well. So now we have the wrong window title. So let's see how that works this time. And we're on this breakpoint. Let's just continue to the one we set a second ago. So GameWindow is null. We step over it. GameWindow is still null. So that's a red flag for you right away. Like, okay, so this is null and it's supposed to have the handle. So obviously there's something going on here. And we know how find window A works. There's a null here, and then you put the title. So obviously there's something wrong here. So you would just adjust that and move on with your life. So the next thing I'll show you here at StepOver, we just changed. Interesting with Visual Studio 2015, I just changed the code and then I stepped over and it just recompiled it and it let me continue to debug, which that wasn't a feature in the previous versions I had. So that's pretty cool. So what did I want to show you next? Let's say we don't care about this whole function. We just step out of, right? Step out and we're done. We're on to the next line after that function gets called. I want to show you some stuff with addresses. Maybe this calculate pointer. So let's put a breakpoint right here and hit continue. This is where we start playing with the addresses, and we need to make sure that everything's kosher here. So I don't really care about that. We want to make sure that the module's getting found correctly. So AC client module is 0. We're going to step over, and now it's the base address, hex 400,000, which is classic. So that's good. We know that worked. Now we have a read process memory call. And what's interesting with read process memory is read process memory will return true or false. True if it succeeded and false if it didn't. So it has error checking built right in. So you could do something simple like this. you know, pool error equals read process memory, and then you could just check that in your watch window or your autos window later on. But I believe in 2015, if we just step over that, it will actually sometimes tell you the result here. I'm not sure how to enable that. But something you can do also is while you're debugging these read process memory calls is to check on it in Cheat Engine and just make sure that it's doing what it's supposed to be doing. We can open up, let's see, struct dissector. That's what we want to do. Okay, so there is the local player address. You're going to type it in there, define new structure, blah, 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 the usual. Why didn't that work? Yes, we do want it to, that seems to be buggy. Let's check out my old assault cube table. We have the local player pointer. Let's go to struct dissector. Let's, I think I've already done this. So AC player structure right there. AC local player with pointer, that's what I want. So there is the address of the local player pointer. And it's currently pointing to nothing. What the hell have I done wrong? 0x50 F4 F4. That didn't do any better. Why is, oh, I have to attach the assault cube. That would be intelligent. So AC client.exe attach, yes. Alright, so here we go. This is the address we had. It's pointing to this address. So when we expand this, we can see that we are at 50F4F4 and it's pointing to 28AA6B8. So we want to make sure that we are reprocessing memory from this address and it's getting stored into local player address. So if we go down here and check the watch window, let's add in local player address, and now we see 28AA6B8. So is that what it points to? Yes. Okay, so we know that read process memory worked perfectly. So basically what you have to do, you just have to step through every single line of code and make sure it works properly. If you step through every single line of code and at the end all of them were perfect, then your hack works. What you're going to find is that as you do this, you're going to step over a line of code that didn't do what it was supposed to do. And then you just edit that, and then you're good to go. You know, a lot of the times it's a stupid typo or something like that. So now let me show you I'm sorry, let me just fire that up again. There was something else I wanted to show you. I'll show you it in the internal project. So here is the guided hacking community hack for Open Arena. So let's get rid of Assault Cube. Let's fire up Open Arena. So here we are. We are compiling in debug, which is good. We have Open Arena open. So in order to attach the debugger, we click debug and we go to attach to process. And then we will scroll down and we will find Open Arena, which is here somewhere. There we go. We have a nice breakpoint window here actually with Visual Studio 2015, which I like a lot. But let's just, we're going to get rid of all of these. So we are attached to the process, but our DLL is not injected yet. Open Arena client, start her up, and there we are. So now we will, let me show you a little trick here. Mamda showed me actually, great guy. So we go to debugging. Nope, that's not what we want to do. We want to right click on the project. We want to go to properties. we want to go to debugging, we want to go to command. We want to open this up, click browse, and then select your executable, the file that you're injecting to every time. You can select it right there. Then you want to go to attach and set this to yes. Now, when you press this play button, it's going to automatically attach to the correct process, which will save you a lot of time, trust me. So we still haven't injected yet, so let's click inject, and we are in DLL main here. We see a create thread call. It calls start hack. We create some instances of the hack objects, and then we hook swap buffers, create an extra thread, and return 0. So after that, the thread's done, and we can see down here, DLL main returns true. So let's step over all this stuff. Return true, step over that. Now all of a sudden we are in a Windows implementation file. So we don't really care about this. So let's click step out of. But what you're going to find out is now we're in the assembly. We're in the assembly of OpenArena. So, and just to confirm this, open up your memory viewer, click go to, and check out 774599A0. And is it move ESI into ESP? Yes, it is. So yeah, currently we are in NTDLLL, which is a Windows kernel file. So we know we are in the process, we're in the OpenArena process, but we are not debugging anything that we want to do. So let's just click continue again, and now the game is running, the hack is there, and let's add a breakpoint that we want to get hit. So in the swap buffers hook, we have an ESP area here, right? So there we go, breakpoint's been hit. We can see in the autos, same thing as the external project, no big deal. In the watch window, we have these items from previous that I was showcasing. So you can add anything you want to here, like I said earlier. CG is a pointer to a game variable, a structure, basically the client game. It's got all these different things. You can edit any of this stuff you want. Frame time, you want to change that? Go right ahead. 15, done. You can change anything you want in here. If you right click on this and click hexadecimal, you can see all those variables displayed as hex. But you can also undo that, but it affects the entire window. So let's say perhaps that you wanted to see the window width is displayed as decimal, but maybe you wanted to see it as hex, but you didn't want it to affect the whole window. What you do is you put a comma and then an H, and now it's in hex. And you can do the same thing with D for decimal. I believe there's a whole bunch of different functionality you can do like that, but those are the only ones that I found useful so far. As I said before, you can use get last error. Check that out. See what's going on. No errors. Fantastic. So another thing I've been doing is typecasting right in the watch window. Let's see. I have this guy here, CGEnts. It's basically the entity list. There is right here, number 2. That's my local player, but that's being replicated from the server back to the client. Normally, if I had bots, they would be right here. So let's say I found I found a player in memory right here. And I don't know what the address of that is. So it's CGEnts 2. So let's just create a new one here. CGEnts. And we can see the address. Oops, let's try this. 2, right? Yeah, so that's me. So that is pointing to my local player. We can do address of, and now we have the address of that structure right there. So we can actually typecast this. It's a C entity underscore t pointer at address 0x06065D4C. Now, we've just typecasted that address to a structure, and when we open it up, it all is in here. So it's fantastic. I'm going to show you one better, actually. I just need to get some bots. Add bots, whoever. And they've been added, a few people, so that's good. Let's execute the debugger again. We're right here, cgents. Let's open that up, and we see, I don't see any other entities there, which is pissing me off because they're supposed to be in there. Give it a second. Sometimes it takes a little bit of time. So let's see who's here. We have Ayumi. Again, the server doesn't replicate their information unless you are near them as just part of their network code. So here we go. We have, I'm still number 2 right here. Type 1 is a player. So we have these people here. So let's say you found my player object in memory and you wanted to see if there were other player objects close in memory. You can do this right in the debugger. It's fantastic, actually. You can call the size of operator on cEntity underscore t, and it's going to tell you that the size, you know what, we need to use my little trick here with the h. So in hex, the size of that player structure is 2d8. So we will take this structure. In fact, we can copy the whole fucking thing. Copy, paste, plus, oh, you know what? Let's see the player that's listed before me in that array. 0x2d8. So, now we open this up, and who do we have? Oh, that looks like a pile of shit, actually. So, why didn't that work? I don't know. cgents, I'm right here. Minus 2d8 should have offset us to this player here. So, what's going on with that? cEntity t, is cgents defined what I think it is? Maybe not. cgents, go to definition, cgentities pointer, go to definition, cgentities, go to definition, it's a cEntity underscore t. That should work beautifully. So what's the holdup here? Oh, you know what I need to do is perhaps I just need to wrap this. And then there we go. Yep, I decided to wrap that in parentheses. So now we can see that this person's information is all correct. So this helped me a lot, actually, trying to find the player arrays. I could always find my player, but I wasn't sure because the way this game works, it creates so many instances of the same objects that I don't know, is my local player in, it could be here in 10 different places, but I want to find the array. So basically I was just checking the next element in the array or the element before me in the array, and if it came up with valid data, then I knew that was actually the array. So I think that's all I can show you, really, with the Visual Studio Debugger. Really, it's fantastic. I use it all day long. Sometimes I wish I didn't have to, and I wrote perfect code, but of course that will never happen. Hope you guys enjoyed the video, and peace out.